I think product design process is completed, right?
Yes, sir. This is completed, sir.
Okay. See that another thing is I think Bharat G's are shared, right? That is Hindustan Petroleum means Corporation Limited. Okay, they called for what is that in mechanical engineer. Okay, so kindly apply for this job because I think there's intake that means there's vacancies of 120. Okay, well, there's vacancies of 120 and maximum age is 2025. So you can apply now. I'm telling for all the students in our okay in the 8th semester. Kindly apply for this Hindustan Petroleum Corporation Limited. So that is it has of 120 vacancies. As well as you can see, okay, that is 1 hour. Sorry, 1 year means you'll be under the okay you'll be under the this one. Then after 1 year, okay, they make pakka. Okay, you means you can means you will work under full time. So I think you will get around 50,000. Initially, only they will give 50,000 rupees. Okay, the pay scale is around 50,000 to 1,60,000. So in between, you will get around from 60 to 70. You will get. So there is, I think, the selection process you can see in the PDF file. Okay, they told the selection process is depending upon the computer based test. So that is 85%, and the group task 5%, as well as personal this interview. Okay, that is a 10% weightage, and final scoring is they will add all these things. I think kindly apply for this. So HPCL, okay, Hindustan Petroleum Corporation Limited, as well as I think HL also. Sorry, HAL also they called for a trainee, right? That is management trainee as well as design trainee. So management trainee 40 vacancies are there, as well as design trainee 60 vacancies are there. So kindly apply for these jobs. I think everyone is hearing, right? Kindly apply for that is HAL as well as HPCL. Okay, it's very important. Kindly apply for HPCL because once you get the job, okay, then it will be easy for you. So there's one another thing is there's 120 vacancies are there. Okay, so depending upon the test, okay, there will be a test. So depending that is your computer based test. That is your technical. They'll ask the technical questions related to mechanical engineering. Okay, kindly read the courses, understand the courses neatly. Try to revise once again every courses. Okay, I think then you can clear this. Okay, then it will be easy for you. Once you enter into the job, I think initially they are paying around 50 plus, so it will be good. Okay, other things you can read in the PDF file. I think Saras shared the PDF file in the group. So kindly apply for this that HPCL as well as HAL. Okay, for both the jobs. So now I will share the presentation. Kindly look into this. So anyone has any doubt in product design process?
No doubt, sir.
There is embodiment design. I have explained in the previous class. What is product architecture? What is configurations design and what is parametric design? Okay. So I explained everything until this in the previous class. Okay, now we will go for methodological evolution in product design. So what is the meaning of this? Can anyone tell me? What is evolution? Why do you want evolution in the product design?
So it is, I think, to adapt changes. So here we are using concurrent engineering, sir. Like earlier thing which was being used, like the steps weren't like interconnected. But here right now in concurrent engineering, all the steps are integrated with each other. So it takes less time for the product to be launched into the market.
Okay, good. So methodological is it means evolution in nothing but okay. We are trying to integrate all the departments simultaneously so that we can finish the what you can say the if you want to develop a new product, then it will be easy for you. Okay, immediately see. So all the departments head, or you can say all the department head, they will come. They'll sit together, and they will work. Okay, so that for developing a new product, okay, it will be taking less time, so that we can supply our product, your new product okay, easily within the like if you use the traditional method, okay, so it was taking around 2 years or 3 years that is before 20 to 30 years back. So right now, okay, it has reduced to from 2 years to at least 6 months. Okay, so now if you want to develop a new product, so they're taking around 5 to 6 months because of this means evolution. Okay, means all the departments are integrated together. Okay, there will all the department heads will be sitting in a single room, and they'll be discussing about whether this design is okay, or whether if you apply this design, okay, whether the product can sustain the load or not. So everything they will do, they will discuss with each other, and they will take the decision, so that all the information will be shared immediately. Example, see, manufacture. So there will be manufacturing engine department head. So you'll be sitting with them. So if anyone asks about the materials, so immediately you will share the information. So that is called as, you can see at the end, information shared source. So that indicates all the information will be sharing uh, at that particular time. So if you use the traditional method, I think if you go for the concurrent engineering, so if you go for concurrent engineering, okay, so if a product design engineer want to ask, okay, I want to ask about the which material we are using, then again you should ask for manufacturing department. Then again manufacturing department will go for assembling. Okay, there is assembling the parts. After that, maintenance. So so after, see, the manufacturing engineer will tell, okay, what type of material now we are using. Yeah, so all the information will be shared immediately. Okay, see, when all the department heads sit in the same room, and if they discuss, all the information will be shared, okay, simultaneously, so that the time, okay, which is taken to produce the new product, okay, will come down. So this is called, see, this is we can do by three process. One is concurrent engineering. By using this concurrent engineering, as well as design for design for excellence, and life cycle design. Okay, by using these three tools and technologies, okay, so we are reducing the time for manufacturing the new product development. Before going to this one, okay, so it covers you can go on the top from the 5 steps, okay, which is there to manufacture any new product development. See here, it covers the 5 main stages of product design and development. So if you want to develop a new product, so there will be 5 stages. One is destination. What is destination, students? What is destination? Hello?
Yes,
Students,
sir.
what is destination? So for the
So
first step is
destination, I think
destination.
it's the market, sir.
The market. Okay. Then in the destination, you can see vision, strategy, and roadmap. So what is the meaning of vision, strategy, and roadmap?
Vision, like where you want your product to be, like after 5 years or something. You said no, sir. Like it should be able to be sold. Like it
Yes.
should withstand sustain life for like 5 years.
Yes. See, for sustaining for 5 years, what type of strategy they are going to do? I think in first model you seen
So they're
PM
gonna
strategy,
analyze
right?
the market, and based on like what will be required for future, they'll be upgrading the product and producing based on that, sir.
Good. Roadmap. See, what is roadmap? What is
Roadmap are the
roadmap?
steps in which they'll be doing the processes.
Yes, to manufacture the product, okay, they will make the roadmap in which machines I should use, what are the tools I should use, as well as what are the machines I require, how much raw materials are required. So roadmap means, okay, they will create the roadmap. Okay, from this process I should go for next. After this I should go for next. So that's called roadmap. Okay, for every 1 month, okay, they will make the roadmap. Okay, so initially they will make for 5 years. Okay, they will try to analyze for every month. Okay, whether we have succeeded uh, the the first month roadmap, or second month, third month, or fourth month. Okay. See, the first step for the any company is destination. First, they should know the vision of the company regarding to the product. If you say the product, so if they tell, if X company tell, okay, my company should um, the serviceability of my product should be 5 years. So that indicates the vision. So my product should sell for 5 years, and for every month I should get around 1 crore, that's revenue. So that is also a vision of the company. So if a company CEO tells my vision is to get 1 crore rupees per month, so that's also vision. So for getting the profit revenue of 1 crore, so what will be the strategy is making? So what is the roadmap to reach the 1 crore, to get the revenue of 1 crore? So what is the strategy is making? So what is the roadmap? So this is called as this is called as first step. That is destination. After that, you can see, yeah, there is discovery. There is inspiration, ideation, testing. What is the meaning of this?
So like assume like you were going out for a survey, like just looking for a problem statement, like you want to make something new product. So if you look outside and if you know what are the problems, then itself you can design a product. So you need
Yes.
to see like what kind of problem is there, and for that particular problem, are there any particular product in the market? If not, how you can look for that opportunity and make a product. So you're actually kind of doing SWOT analysis over here.
Yes. Good, Sachin. Good. So discovery, that is inspiration, ideation, testing is nothing but see. The CEO can tell means I want the profit, I want the revenue of 1 crore rupees per month. So without selecting a product, okay, depending upon the customer needs. Okay, if you select see, without selecting the product, we cannot gain the revenue. So we want to select the product depending upon the customer need, the society, this what the society is asking. After that only we can go for the ideation. Ideation means idea generation by brainstorm session. Okay, we can get the idea so that we can give the product according to the customer needs. Okay, after doing the ideation, then go for the prototype. That is your manufacture the products, and do the testings. If the product is good according to the needs of the customer, then we can the supply the products for the customer. Then only we can get the revenue. So the second step is to get inspired in the sense of okay, what type of product I should do according to the customer needs. As a CEO, as a design thinker, I should analyze what type of products I should select. I means inspiration. I should get the inspiration to work on the product. So what is the need? So if I take this product, how much revenue I'll be getting for each product? Okay. So example, if you take a pen, so how much revenue I'll be getting when I sell one pen? So like this, if you want to get 1 crore rupees, there's revenue for 1 month. How much pens I should share? I should sell. Example, if the pen rate is 10 rupees, okay, if you're investing around 7 rupees, so 3 rupees is profit for one pen. If you want to get 1 crore rupees, so 3 rupees, how much you should sell the pen? So you should sell around 1 lakh, two
So
lakh,
1 crore by 3, sir.
that
No,
much.
1 crore by actually 10. So for that you'll be getting a profit. No, 1 crore by 3 into 10, I think so.
If you do, see, you should know how much pens I should sell in the market. Then only you'll get at 1 crore. So that is the aim. That is the vision. So the as a CEO, you should know which product I should select. For this product, how much I will get revenue for each product. If I sell this much product, I will get 1 crore rupees. So you should know the vision. Okay, as well as roadmap. Roadmap means how much I should sell to the market. Sorry, how much product I should sell in the market so that I will get that 1 crore rupees. So inspiration is nothing but which product I should take. So simply I cannot take the pen as my product, or phone as my product. Simply I cannot take, depending upon the customer needs. Okay, depending upon the customer need, I should analyze. So if I sell for the, if see if I'm investing around 10 rupees for producing some product, if I'm selling 50 rupees also, 50 rupees, if the customer is asking and is taking means, so that indicates the customer needs that. So we should analyze which product goes well in the market. So if I'm investing 10 rupees, and if I'm selling for 1,000 rupees, okay, if the customer are taking, so that indicates the customer needs that type of the product, right? So we should analyze which product, okay, is having demand in the market. Okay, we should select that product, and we should manufacture, and we can sell for high price also. Okay, depending upon the customer needs. So that's called inspiration. Which product I should take as my product to sell in the market? Okay, then only we'll go for ideation process. So once I select the product, depending upon the demands which is required in the market, I will select the product. Okay, I will get inspiration depending upon the customer needs demand. Then I will go for ideation test. Okay, if my product goes well, then I will supply for the market. Okay, so see, initially I told you from 50 years back they were using the traditional method. Okay, after first step they were going to second step, third step, fourth step, fifth step, like that. Okay, I will explain you anyway. I will explain you about that concurrent engineering in the next slide. So after this, the second stage, the third stage is the definition and design. What is the meaning of definition and design?
The definition here might be like what kind of problem you are solving. So you need to at least like specify what are the users of your particular product, and design might be like the conceptual design. So like people or like your the other departments just get a general idea of what type of product you're making and what it will be used for.
Good, good session. So testing, see, this testing indicates in second step. Okay, it's not about it means you're supplying for the customers. Okay, once you get the idea, okay, we will try to convert that idea into one or two prototype and we will test. Okay, if it works, then we'll go for the development of the design. Okay, if you see example, I think yesterday I told you, right? The first, I think you can see these four designs. Okay, the bracket. The first I will try to first I will try first design, second design, third design, fourth design. So which one goes well, I will take that. So that is my product, and I will try to optimize that, right, again. So if optimization process is required for that design, then we can do optimization, right?
Yes, sir.
So likewise in the same way. Okay, after testing, after when once you done the testing, if it goes well, then again we can go for the development of the design if it required. Okay, if you want to do any optimization, you can do in the third step, that is definition and design. Okay, you can go and you can redesign the model by doing the optimization process. After that you can go for development. Development is nothing but what? Development means what? Development of the design. So convert your final design into the product, right? So right,
So
students.
development is just producing the product, sir.
Yes, that is development is nothing but development phase. See, once the design is finished, so then we will go for development, right? Development of the product. Then after that, data and optimization. So what is the fifth step? Can you tell me what is this data
So
and
like I
optimization?
think you're storing the data of the product, like the 2D drawings and all those things. So later when you need to update the thing, you can just edit in the existing data and make a better product.
Okay, that is one thing. And second thing is nothing but, see, once you develop the products, okay, uh, then you will sell the products for in the market. Then we will take the data, right? Data, how much it has been sold, everything, data. And if okay, and if the customer tells that, okay, if this design is not good, or in design something is not well, then then again we can go for optimization, right?
Yes, sir.
So depending upon the customer reaction, okay, we'll get the data. So how much has been sold in 1 month, or how much it has been sold in one day. So we'll get the data, how much product has been sold, and according to the customer requirements, okay, we'll try to do again the optimization process. Okay. Okay, so this is about the what is can say, this is called as the 5 main stages. Okay, of the product design and development phase. So when you come for the methodological evolution, okay, this is the steps. Okay, these are steps involved in the product design and development. So when you come for methodology, I told you in the previous 50, I think from 30 to 40 years back. So they were following the from one step to another step, like idea generation. Once you get the concept, okay, then as a design thinker, okay, you'll be sitting and you'll be getting the ideas. Then you'll be converting that into the prototypes. That is your sketch prototype. Then the product design engineer, will see that, and they will send that product. Sorry, you will send that sketch prototype to the design engineering team. Then then you will be converting the sketch prototype into the real prototype, that is 2D drawings, then 3D drawings. Then then after that it will go for FEA, okay, fine element analysis. In the department, if it okay that this design is good, okay, this design is withstanding the load, okay, which we are applying to that application. Then it will come back, that is will come back to product design department. Then after that, okay, as a product design engineer, okay, you will send the design to manufacturing. Then manufacturing department, manufacturing engineer will send that design to the employees or the supervisor, okay, who will be working under the manufacturing engineer. The supervisor will again he will send the design to the employees. Then the employees will convert that design to the product, right? After that, means producing the parts, then it will go for assembling of the parts. After that, it will go for maintenance, right? If any maintenance is required, then after that we will supply for the market. So this is the regular process, traditional method, okay, which we are following before 30 years back. From last 20 years, okay, from last 20 years or 15 years, we are using this concurrent engineering. So what is this concurrent engineering?
So like all departments are interconnected, so there's proper there's improved data flow, so they can come up with a better product at a lesser time with a better quality.
Okay, good. So example. Anyway, okay, this is an example I'm giving
The
you.
example we can give mechatronics, no sir?
Yes, mechatronics also, it is integrated of all the computer science, mechanical, electronics, so everything is combined in that, right?
Yes, sir.
Now all the departments are combined for a single product. If you want to manufacture, like if you go for washing machine right now, you want mechanical systems. There is materials you required. You want means you want electronics there, like circuits. So then you want computers. See, I think computers is not required in the washing machine because we are not programming anything. So if you go for CNC machines, so there you require everything, right? You want circuits, you want programming, you want mechanical components. So everything will come in the CNC
So
machine, right?
even in washing machine we require, sir, ladder logic programming is required. In that we have AND or OR gates, sir. Like recently in mechatronics, sir was teaching us that.
Okay, washing machine. But actually, if you write the programming,
So
means you want to
in
write the
that what
program,
they are
right?
doing is like they're converting the program into simple inputs like us. Like we press on button, so when it is turned on, the
Mhm.
other switches like are turned off like that, sir.
Okay, so that is that simple way, in a
Yes,
simple
sir.
way,
So
right?
that's like converting the program into simple inputs, like so it is like user friendly.
Okay. But actually, if you take CNC machine, if you want to write programming there, so we want the computer science, then we want electronics by for circuits. Okay,
So we
then we
can
want
say automated
mechanical.
production lines, sir.
And so there also. So right now, if you go for industry, everything is means everything is involved, like a material science. Sorry, that is mechatronics. So we want mechatronics everywhere now. That is combined of all the branches. Okay, mechanical, electronics, electrical, computer science. We want everything in a single product. So this is an example what I'm giving to the mechanical system. Okay, so I'm discussing with respect to only mechanical manufacturing of the product. When you want to manufacture the products, so what are the steps it was taking in the previous, I think, 30 years back. But now they are integrated everything. Example, you assume that, okay, the design thinker has done this job. Okay, he has supply and he has given the idea generation to the product design engineer. Okay, he has also converted his idea to the 2D drawing, to the sketch prototype. Then he'll send for the design engineer. Okay, he has done everything, and in analysis somewhere it has gone wrong. Okay, it has gone wrong, means he has done wrong, and he has told that, okay, this design is okay. Okay, immediately as to this design is okay. Okay, we can go for manufacturing. Then the product design engineer will supply to the manufacturer department, manufacturing engineer. Okay, assume if manufacturing engineer got the idea that, okay, this material could not sustain the load. So again, see, manufacturing engineer should come back to the product design engineer, and they should tell this design is not okay. Then again, the product design engineer should tell for the design for the FEA team. Okay, whatever you've done, okay, it is again, you means you should redesign, sorry, redo the FEA, fine treatment analysis, and you see whether the material can sustain this load or not. So this process takes a huge time. Okay, now what they done in concurrent engineering means, okay, all the department heads will be sitting in the same room. So immediately, see, after doing the idea generation, okay, immediately that idea will be given for the product design department or product design head. So you will convert that ideas, okay, into the sketch prototype. Okay, once he has done this script prototype, immediately he will apply for the what you can say the design engineer. Before sending to the design engineer, okay, you will show the design for all the manufacturing head, then assembling, maintenance, everyone will be there in the room. So you will be showing everything. So you will be showing the design, the sketch prototype for everyone. So after uh, all accepts, then only you will send the so that design for the design 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 department. Okay, design engineer. After completing the design part, again you will send the 2D drawings and 3D drawings for the product design engineer. So again you will show everything, the design for everyone. So if all the people, if all the aides tell okay, then only it will go for the FEA team. Okay, immediately they'll do the analysis, they'll give the result for product design engineer. So everyone will see there itself. Then the product design engineer will convey the message for the manufacturer, the manufacturer. Then after seeing A itself, okay, you will send the 2D drawings for the supervisor. So by this, okay, by this method, okay, the time is reduced. So this is called as the concurrent engineering. Okay, yes, kept that as concurrent. See, concurrent is nothing but done at the same time. Okay, concurrent means done at the same time. So if all the process will be they'll be taking in the same decision, will be taking at the same time. I think everyone is getting right. So immediately once the design is completed in the from the design engineer. Okay, once he supplies that 2D and 3D drawings for product design, he will show the design for everyone. That either he may be CEO, or he may be the manufacturing engineer, or he may be analysis team head, or he may be the assembly head, or whatever it may be. Okay, the heads will come there, and they'll be sitting. Immediately he will show that 2D drawings and 3D drawings for everyone if they accept, as well as the customer also. Okay, here the customer will be sitting. So everything he will show, the design part he will show for everyone. If they accept, then only it will go to the further steps. So this is called as concurrent engineering. So everything, okay, will be done at the same time. Okay, that is accept. If design should be accepted, so everyone should be accept at the same time. So after going to the assembly, okay, again the assembly person, okay, who's in that, okay, you should not come back to the product design, and you should not tell, okay, the design what you made, the tolerance is plus or minus zero point 0.5 or plus or minus 0.2 showing in 2 runs. Okay, you cannot come and again tell for the product design. So if they accept at the initial stage, then it will be easy. Okay, easy when it goes to, so when it goes to manufacturing the products, right? So that the time will be saved here. So right, students.
Yes, sir.
So this is nothing but it is called as concurrent engineering. So what they decide in the company, okay, so the CEO told everyone head will be sitting in the same room, and they will be discussing. Okay, if something happens, if design is not good, immediately the manufacturing department head, he can tell that this design is not good because it cannot sustain the load, or here some design should, we can optimize the design here or not. Everything they will discuss in the room, and they will finalize. Once they finalize, then only it will go for manufacturing. But in traditional method, okay, it was like after doing the ideation process, that is then it was coming to the product design engineer, then it was going to the design engineer. Okay, so at that particular point, no one will see and they will approve in the traditional method. So at that particular point, okay, while in the while assembling stage, okay, some of the products were mismatching. So only they converted the traditional method to the concurrent engineering. So concurrent means everything, okay, will be the decision will be taken at the same time. So once design is fixed, then it will go for manufacturing. So all the department heads should agree that 2D drawings as well as the 3D. Then only it will go for the manufacturing. Okay. So this is about the concurrent engineering. So anyone has any doubt?
No doubt, sir.
So before that, so in methodological evolution in product design, so there is three. Okay. So that is a new method is introduced. So they eliminated the traditional method. So going in a straight line. Okay, that is linear. So they told we should not go linear way because it's taking more time to manufacture the products. So they told, oh, we'll go for non-linear. So non-linear means, okay, everyone should sit in the same place, and they should finalize they should finalize the design, materials, or whatever it may be. Everything they should decide first. Then only you should go for manufacturing. So that is called as information shared source. That means every head will share their information regarding materials, regarding how much raw materials are required, how much product we can manufacture in the by using the machines. So everything will be shared at the at, means at the starting point. Okay, so this is called a simultaneous or integrated design. So everyone will sit and they will try to uh, analyze, okay, in what way we can complete the new product within less time. Okay, see, then after taking the decision, then only it will go for the production ramp up. So ramp up means what? The production ramp up. Can anyone tell me what is this production
So
ramp up?
increasing the production, sir. Like you just try a trial run, and if you see like the customer liking your product, you increase up your production so you can meet the demand of the customers.
Yes, the ramp up is nothing but it is the production of actual products. So first we will do the prototype. We will test if it is okay. Okay, in this stage, that is integrated design stage, then it will go for the actual production of the products. Then it will go for the market. So this is called as the production ramp up. So we will try to produce more. Okay, then after that we will supply for users depending upon the what you can say information. So that will be given by the users. It will go back to again need identification. If your product has some weaknesses, so again we should try to eliminate those weaknesses in your product. So again it will go for the need identification. As a design thinker, we will go and we will ask again for the user. So after, see, once I supply my pen to the customer, okay, I should ask whether this pen quality is good, whether the design is good. Okay, where so what are the weaknesses of my pen? So everything I should ask. Once I ask for the customers, again they will tell the needs. What are the needs they require? Okay, then again it will go for project definition. Again all the department heads will be sitting in the same area and they'll be seeing what are the needs they require. Okay, as a design thinking team, they will give the ideas. As a product design engineer, okay, you will do the sketch prototype. You will give the sketch prototype for the design thinking, so design engineer. You will convert that design, okay, to the 2D and 3D drawings. Okay, so everything they will take decision and they will go for manufacturing. So this is called as concurrent engineering. So right now they're using this concurrent engineering as well as see. You can see in this slide. So in the new methodological evolution, so there are three terms. One is concurrent engineering. Second is design of X. That is design for excellence. And last is life cycle design. So these are the three. Okay, if you follow these three process, then it will be easy. Then it will be easy for producing the products early. Okay, within less time, and you can supply your products for the market easily within less time. So use these three methods. See, all the companies right now they're using the concurrent engineering as well as the design of excellence as well as the life cycle design. So by these things, okay, by using the design of excellence, okay, so we can know so how much years the material can sustain. So which material I should use. So what it is. So how much what you can say how much product I can manufacture, okay, in 1 month. Okay, so what is the design of assembly? Then we can go for what is the quality of the products, how much quality we should give the products for the market. So what is the reliability? So what is the survival? What is the maintainability? Okay, what is this the serviceability? Then about safety. Okay, we can tell all these things. Okay, in the DFX, that is designed for excellence. Which, okay, we can assurance and we can tell for the customers. Okay, what is our lifetime of my product the product. Okay, what is this quality of my product. Okay, what are the things, okay, what we are giving for you. What is assembly, what is the design for assembly. So what is the design of the manufacturing. So everything we can find and we can tell for the customers. Okay, concurrent engineering, right? So concurrent engineering is nothing but to reduce the cost and to reduce the time. So we use this concurrent engineering. So you can see in the context of this new simultaneous integrated statement, three approaches are currently the subject of much of the research regarding design methodologies. So these are the three important what you can say approaches. Okay, what the industries are using. One is concurrent engineering. So now only I explained you about concurrent engineering. Okay, so next is the design for X. That is design for excellence. Okay, that is high quality. Excellence is nothing but high quality products. Okay, you should supply for the products to supply high quality and high serviceability. What you should do, so you'll be seeing in design for excellence and life cycle design. In life cycle design, you can see extend the field of design analysis to the entire life cycle of the product. So here you'll be telling, so okay, how much time you can use this product, okay, and after that, okay, the disposal time. So example, you can use the pen for 1 month, or you can use the pen for 2 months. You can use this pen for 3 months. So this is about life cycle design. So if you design any product, you should tell the life. So I'm telling 5 years. So this is called a life cycle design. So by using this life cycle LCD, you can tell the you can do the analysis and you can tell the how much years this pen can sustain or that product can sustain. So these are the three important approaches what the companies are using, and they are telling about the product. Okay, about a single product, they will be telling about what is the quality. Okay, how much I can manufacture, the products for 1 month. So what will be the reliability, how much year the material can sustain. Okay, after that, how much year I can give service for you. Okay, after that, how much year on the end you can tell the product retirement. So how much year the product may be retired. So anyone has any doubt in this
No doubt,
slide?
sir.
So I think this is over. And okay, these are the main three methods you should remember when you go for the companies: concurrent engineering, design for X, that is excellence, life cycle design. Okay, and you should know what is this analysis and synthesis. So this is very very important. Okay, what is interconnected analysis and synthesis action?
So
And I
I
will
think
explain you
as
everything.
this thing, what you say, as you said, in concurrent engineering, the departments are interconnected. So what
Yes.
they can do is like they can find problem at an earlier stage. That's what analysis is, and they
Hmm.
can provide better solutions so that it will save time instead of finding the problem at the end stage. You can find it in between and correct it that time itself.
Good, Sachin. So, example, I told you, if FEA team makes mistake, okay, in the traditional method, it will take more time for the company, okay, to analyze. So where we went wrong. So if all the department heads sit in the same room, and if they discuss, okay, so they can analyze so they can think, okay, about the analysis. They can do the analysis where we went wrong, so that they can give immediately the what I can say the solution. Solution is nothing but synthesis. So synthesis is nothing but giving the solutions. So analysis is nothing but getting the information where we went wrong. Okay, so the why we went wrong, everything we can ask in the analysis, and synthesis we can give solutions for that questions. So immediately, if means if the team is integrated, okay, if they sit in the same room, if all the department heads, okay, they can do better work. Okay, immediately they can ask the questions for what side the material has failed, and they will take some time and they can give solutions for that. Okay, so that we can reduce the time. Okay, and we can supply the products very early, very early to the market, and we can get success in the market. And design for X, I told you, so involves a flexible system of design methodologies and tools. So here we can use the design methodologies and the different tools what we are using. Okay, to make the product quality high. Okay, then LCD. I told you about LCD. I think content engineering anyway I explained you. The same thing I should explain once again. Okay. See what are the gaps? Here it's very important. See, function overlap is nothing but, okay. You can see at the end they mentioned the function overlap. Okay, we should see what is function. Can anyone tell me what is function? What is function? I
So
told you.
function, like each department has a separate function. Like the design team is to make a design, analysis team to analyze the design. So like each department will have separate function for themselves.
Good. And the other thing is depending upon the customer needs. So there's a function. So if the customer is asking the product which should function like this, So depending on that only, I should manufacture the product so that it should work whatever the customer is asking. Example, if the customer is asking, I want a car, okay, which is moving with respect to 1000 kilometers per hour or 1500 kilometers per hour. So that is my function, right? So the function is the car
So
should be
is it the features you require, sir?
that is future is okay, but depending upon the customer, say the customer is asking this function. So I want to go in a car that is 1000 kilometers per hour. I don't know whether it is possible or not. But but the company aim is to reach that goal. Okay, that is we should manufacture a car which is moving 1000 kilometers per hour. So that is the remote function. Okay, that is called as function which we should reach depending upon the customer needs. Okay, see the function overlap means, see here in the traditional method it's very difficult, right? Because we don't know whether the material or whether the design is may fail in the assembly part, because see there will be thousands of parts will be there, so we should assemble the 1000 parts, right? So if one design varies, if one design tolerance varies, then it will not fit in one part, right? Example, if shaft, if the required shaft size is 25 millimeter, if if it goes like 25.5, so it will not fit, right?
Yes, sir, it won't fit, sir.
So in traditional method, okay, you will get the information while assembling. So it's very difficult. Again, issue the assembly who is the manager. Okay, immediately you should tell for manufacturing department. So you should stop the manufacture. You should stop the manufacturing of shaft. So in traditional method, it was very difficult. When you come for the concurrent engineering, it's very easy because everyone will be saying the design. So once the design part is okay, so the as a product design engineer, you should show the design for everyone 2D drawings. So immediately, okay, everyone the product, either it may be the manufacturing department head or assemble that is manager. Okay, you look everything. You should approve there itself. Okay, there will be no problems when you go for manufacturing the parts or when you go for assemble. So there will be no problems occurs. Okay, in the concurrent engineering. Okay, so that is called as function overlap. So function overlap means in traditional method, okay, some overlap will be there depending upon the, see one may see one may see one can means one cannot see all the 1000. I think if there are around 100 as 100 parts, so as a manufacturing engineer, okay, you cannot see 100 drawings and you cannot approve immediately. So if you come for concurrent engineering, so the different, there will be a lot of department heads will be sitting and you'll be looking into that. So anyway, if some error is there, immediately you will tell. So this is the error. In 2D drawings, see this part and this part. So they say vary. The dimensions are varying. So immediately we can check and he can tell. Okay, in the concurrent engineering. So these things cannot happen in the traditional method. So this is called as overlap. So overlap in sense of here the overlap will not happen. So easily it will function. So all the department heads will be sitting and they will be analyzing the details of drawings. So this calls concurrent engineering. So anyone has any doubts? I will go further. So this is very important. Okay, this slide. So what does it says, Sachin? This slide. Can anyone tell me?
So I think this is what, like you said, no, sir. Different departments are all together, so they assign task and to a specific team, so they can give approximation like how much time they'll require, and by that time, like assume you're making a product, so you give a design. So at that time itself, you have the other team which will be giving you the material selection based on what features you require. And by
Yes.
that time itself, the analyst team will see like how much material can be removed and how much it can be utilized, like optimized.
Yes. Yes. Hmm.
And then the technology part is they can just run through software and see based on what machines they have, like is it enough to make that particular design, or they can make the changes that time itself. And on the simulation software, you can get the time, like how much time is required to manufacture the product. So if it's meeting the requirements, like they need to produce a certain amount of product in a month, and if they are able to use it using this process, then they'll go with it or they'll find alternatives for it.
Okay. Good, Sachin. So these are 70s wherever you go in the industry, this is they'll ask. Okay, concurrent engineering. So they'll be using this concurrent engineering. They will ask this, what is, can you tell me 70s? So 70s are nothing but talent, task, teamwork, techniques, then technology, time and tools. So if you want to manufacture a new product development, all the 70s are very important. The talent in the sense of to make the design. So you want talent, right? Talent in the sense of you want creativity. So if you have creativity in your mind, then only you can develop a new product. You generally you can develop a new design, right? Then task. Task is what do you mean by task? What do you mean by task?
So are those the activities you must perform, sir?
Yes, the activities you should perform to manufacture the product. Then teamwork. So teamwork is nothing but in concurrent unit team of it. All the department heads should be there in a room, right? So they should discuss and they should finalize. Without teamwork, okay, the concurrent engineering will not what you can say will not be sustained. Then techniques. So which are the different techniques you are using to convert your raw materials into the finished product? So we should decide here itself, as well as the technology, which type of technology we are using. So if you go for analysis, you want the computers, right, to do the analysis. Without computers we cannot do the analysis, right? That is your answers. Your numerical method we should do in system itself. That's called technology. Which type of technology you are using, and to get the results, like to get the stresses which is induced which is induced in the material, we should do the numerical analysis by using ANSYS, Abacus, Nastran. For designing also, for designing the 3D model, you want the system, that is technology. So what type of technology you're using? Okay. Then time. How much time you require to complete the task? Means completing the task, how much time required? That is to send your product to the market. So how much time you take? Then tools. What are the different types of tools? Okay, you will be using to complete the task. So these are the 7 T's. Okay, it's very important in concurrent engineering. So first they will write the talent. You want talent to complete the design, task, teamwork, techniques, technology, time, and tools. So these 7 T's is very important. So these slides, I think this theory is not there in the book. Okay, in the notes it is not there. I will give you this book to, it means you can see in the PPT. Next, we'll go for organization and decomposition in product design. So, what is the meaning of this? Can anyone explain this? Anyone can explain what is the meaning of this? Organization and decomposition in product design.
Sir, like I think in this is like you are distributing the work to different people based on their functions
Okay, good.
in an organization for the product. So like
Good.
the things can happen at a faster rate. Like assume you said this earlier. Like assume there is a product, so it has several parts. So instead of one person doing it, it will be divided into several people. So they'll be able to produce it, and they can be like the overall parts will be produced at a lesser time. So it can be assembled at a faster and can be launched up to the market at a faster rate.
Okay, good, Sachin. It's the same thing. So I'm telling, the understanding is same. So decomposition indicates breaking it down into single task and determining the structure and this interaction, linking these together. So it indicates we should break. If you want to manufacture a product, okay, we should break into number of pieces. So what you'll do in FEA? So we will take the structure and we will cut into number of pieces, right? Likewise, we should cut. If you want to manufacture a product, we should cut into number of pieces and we should explain. Means one step into one step. The first it is brief. We can see in this sketch: brief, initial concept, detailed design, pricing, prototype, put product on system, order material, and production. Right. So these are called as sub steps. Okay. Decomposition is the thing, but breaking it down. Okay, means we will break into number of pieces so that it will be easy for us to complete the task. So that is called as decomposition. So in an organization, they will do this. Okay, decomposition. If you go any company, they will tell decomposition. Do decomposition technique and finish the task. So decomposition is nothing but that is breaking it into number of parts. I think everyone has understood, right?
Yes, sir.
Okay, you can see in the top, the phase of development process planning consists of a decomposition. So decomposition is the thing, but breaking into number of parts. Okay, planning. After breaking this into number of parts, then we should plan. So distribute of all the activities. Then we should distribute the activities what each individual should do. Then resources is nothing but what are the raw materials will be required, what are the tools we required, what are the technology, what are the machines, everything will come under resources. And information involved in the entire process under construction of the product. I forgotten to write this, of the product or manufacturing of the product. Okay, to manufacture a product. So what are the steps the organization is taking? Okay, that is called decomposition. So cutting into number of pieces or breaking it into number of pieces. So this is called as decomposition. So anyone has any doubt in this? So the same way, see, I think if you go for the next product design process. Okay, so this also is called as number of steps, right? So if you want to convert your product, so first see define problem, from define problem to detailed design. So this also is steps, right? Sub steps. So right, Sachin. So of one
Yes,
after
sir.
one. So one after one. So it is called as decomposition. Okay, it is called as decomposition in the company. Okay, first here brief. First, if you want to, if you selected some product, first we want to brief that. So what type of product we are taking. Then initial concepts. Concept means ideas. The idea generation depending upon the customer needs. See, next detailed design. So before going to detailed design, you want to know about all these things, right? So right, Sachin, that is your means your conceptual design, your means embodiment design. Then only you can go for detailed design, right?
Yes, sir.
So initial concept will convert into the product, that is detailed design. Okay. So here you can see design chosen by customers. So you should show the design for the customers. If they accept the concept, then only we can convert into the detailed design. Then after that we should price the product. So you should choose the material, which material we are using. Then at the end, okay, we should keep the pricing. How much price I should sell the product. If the customer is approved, then we'll go for prototype. Okay, prototype means converting the concept into the product. Then put product on system. What is this put product on system means?
So is it like analyzing and all those things like before producing it, you can manufacture like digital like on the software. So you might
Yes,
get to know like what machines will be required and how much time will be taken to produce the product, or
yes.
it can even be analyzing the product.
Yes, good Sachin. So you see all these things. Okay, while going through the process, see always we should ask the customer. If the customer approves the pricing, then we'll go for prototype. Okay, for testing whether this product will sustain to the load or not. Okay, then design approved by the customers. Once this 3D drawings is approved, then we'll go for put product on system. That we should analyze whether the product is okay with respect to that much load, means it can sustain the load or not. Then order the material. Okay, once you do the FEA, okay, once it is okay, then we'll go to the order of the materials. Then we'll go for production. Okay, production of the products. Then we will sell the product for the customers. So this is the process. Okay, it will go in it will go in the company. Okay, in any organization, the same process will follow. Okay, so here initial concept to detailed design. Okay, there you will study the product design process, right? So anyone has any doubt in this?
No doubt, sir.
I think tomorrow we'll go for design for X. Design
So
for X.
tomorrow holiday, sir.
Okay, okay. Anyway, so design types of design. So these things, okay, these things are not there in my notes. Okay. So anyway, I should explain these things. I think today organization and decomposition of in product design is over. And concurrent engineering and methodological evolution in product design. If you have any doubts, you can ask me. I'll give 1 minute time. Then I will take the attendance. So don't leave the class, students. Okay, I will take the attendance now. Any doubt, students? I can leave the class.
Yes, sir. No doubt, sir.
Okay, thank you.
Thank you,
Thanks,
sir.
thanks. You can leave the class.